So we come now finally to introducing the concept of a class. Bear with me a second, let's change the colour. Now, it depends, a combination of how you want to think about this and how we want to grasp this. But let's go back and try to introduce what the concept of a class is doing, and then we'll go through how you build one up using the stick figure and so on. So let's go back to our example. We wanted to create a simple stick figure, and we wanted to use a bit of code to construct one, and we wanted to pass it some initial values. Now, later on, we can look at other kinds of ways of constructing a stick figure. You might not just want to pass it the initial values, you might want to pass it the window to draw it on, and so on. Now, bear in mind throughout, when we come to this type of programming, there are so many varieties and variations of how to code. Okay, so keep that in mind. In these lectures, I'm going to try to keep to the simplest version, but not always necessarily the one that you might think is the one that really makes sense to you. So if you remember what we were trying to do from the previous video, we want to do this. We want to create our stick figure, then ask it to draw it, and later on in our client code, we want to be able to undraw the whole stick figure. Okay, what we pass to it will be a window and be a window. Okay, and again, this question of what we pass to these will change. And also we're going to have a change of language. Here's the first concept, change of language. In procedural programs, we tended to use the word function. In object-oriented code, we use the word method. I'll try to maintain that distinction, but keep your mind clear on it. So, what's going on behind the scene to allow me to do this, this, and this in my client code and actually make my job really, really, really quite simple? And remember, if you design any kind of object in the form of what we call a class, give it some rules of how to build it, then use it, you will find this incredibly powerful. And an exercise some of you may already leap at is taking your Python coursework that you submitted right at the end and revamping it using classes. Now, although we have plenty of exercises and I supply you with separate ones, you might, for your own interest, test that out and see how that would change your code. It may deepen and help your coding. But I'm not necessarily recommending that at this stage. We've got a lot to do. So here now what I'm going to assume is a separate file, and I'm going to say I create a file and I call it stickfigure.py. Notice a couple of things. That's capitalized, that's capitalized. Inside this file, I'm going to import graphics. So I'll have my usual graphics import. And this is important to note, import star. Whenever you use classes, anything you need within that class you would use this import statement from graphics import, or from this you would import, and we are going to make use of this a lot more than you did in the first semester, because the class that you create, in order to use it as an object and create and make stuff, you need to import that class to make it available to you in another file. And we will talk about files, because the ideal is that you have one file which builds and designs your class and another file which will test that. And that would be that would be your client or your testing code, and that would be your server. Okay, now I've jumbled up the screen. I'm going to get a fresh one, and we're going to go through what the class does and how it looks. First thing to observe is that you use the class keyword here, and then you write the name of your class immediately following. And in our case, we're going to do stick figure. Notice both first letters are capitalized. We then have a colon. So what happens from here on in is that any code I write here, inside here, needs to be indented so it belongs to the class. Okay, that's the first thing to observe. The second thing to observe is that inside this class, I'm going to write various different defs, okay, and we'll explain that. But what this class does is it doesn't give me the order of execution. It doesn't mean that if I write one def here, then another one here, that when you create and use this, you have to use them in this sequence. It doesn't work like that at all. Let me just try to be absolutely clear. With class-based thinking, if you imagine there's your class, right? So this is my stick figure class. This stick figure has an interface. One of its interface elements is a draw method. One of its interface methods is an undraw method. So the point is, if I'm using this code and I create an object out of this, right? So I create my SF using that equals stick figure code we've had before and pass it whatever I need. I then have my object, but it doesn't mean that I'm forced to use these methods in this sequence, in some kind of linear sequence. I can use whatever I want in any sequence I want. So if I want to draw, I would just call the draw method. If I wanted to undraw, I'll use that. They are not drawing on each other. They're not part of a sequence of code. In procedural code, it tended to work a little bit different. But here's a crucial element. Your class, think of it like this, okay? This is a class, and this will build your object that you will then go and use, okay? Now, what I'm going to say needs to be qualified. For those more experienced will understand that this is generally true, but actually, more importantly, from your introductory level, critically true. You tend not to use a class directly. The majority of cases are you create an object from it and then you use the object based on that class, and that's quite crucial. Sometimes you do use a class directly, and that's called, in other languages, called a static class. It doesn't store anything, and it's just an organizational structure. But we're not interested in that, and that's quite an advanced concept. So please bear in mind that this is introductory, and throughout everything I say, I will try to catch myself if I say an inaccuracy. So this will have a number of methods. Method 1. And the logic of the method, and it will have another method, method 2. Internally to the class, it will store some data, some values, some information. And the basic logic is you interact with the class through its methods. The method, you pass it some values, it gives out some return to you. Internally, the method might use other methods, but it might interact with the data and give that information back. So this model is really critical. It's a shift in the way that you think when you code, because it's all centered on the notion that a class builds an object. A class is a black box. It is ideally hidden from the rest of the world. Now, in Python, you can't really hide the internal workings. In Java, you can. So that's a really, really crucial concept, because you only can interact when you create the object and you interact through these methods, which become part of what you might want to call its, let's use a different color, its interface to the world. Okay, now the vocabulary for this unit and for the rest of the semester won't get much more complicated. These words will repeat themselves again and again. Let's get back to our stick figure. So we had a keyword, the word class. Then we had the name of our class, which was stick figure. Then a colon. Then we had a number of defs. Now, if you go to the files, that the worksheet, the practical sheet, you'll see all this code there. But let's just talk it through. The most crucial and the strangest piece inside a class is what's called the code to construct a class, the constructor. So let's just focus on that a little bit. We're interested initially, I'm going to put a hash in there, the constructor. How do we construct an object from this class? So in Python, you do it like this. You write def, and remember this is indented, double underscore init, double underscore, and the word self, comma, right? We'll explain all of this stuff and we'll talk about it. And then any values you're passing in. So we wanted to pass in the X and the Y value, didn't we? Okay. So that is the signature. Let's get the green back again. That is the signature for the constructor. It says, in ordinary language, I've got a constructor. This double underscore init is the language Python uses for its constructor. So you're given this. You don't have to invent this. This is a kind of fixed, reserved concept. Open a bracket and you'll notice this word self. Whenever you have any use of def inside a class, the first parameter always will be the word self, and I'll explain that later. You have a comma, and then you have the values that you actually are the external parameters coming in, which you're going to do stuff with. Now, this is quite a complex, tricky idea. So we're going to go through this quite slowly by contrasting what we did before with what we're going to do now. So first of all, we if you remember, if you can think back, what we did, let's use a different color, is we had the head, which I'm just going to temporarily call head, and I haven't put strict indenting, but make sure you do. And we had the circle, if you remember this, and all the information to create the head. Okay. Now, this constructor would seem logically to be the place where you construct your head, your arms, your body, your leg, etc. But it's not that straightforward. It does something more. In front of the word head, I put the word self. And why do I do that? Well, this word self that appears in two places inside this, and remember, the rest of the code would look almost identical to the previous code, and you can see that would be self.body, a line with a point, with this XY adding into all the points, as we discussed in previous videos. If you haven't watched them, go back and watch them, because this won't necessarily make sense. But we have two words here. We have this word self. We've talked briefly about that. That's a given term, right? Won't worry about that. But the term self here. Well, this self here is a way of saying that this is no longer a function, but a method belonging to a class. Self is a way it binds this to the class. If you just wrote def and you wrote a function and dropped this, it would complain. It would say, sorry, you can't have that inside a class because it has to be bound to the class. And the way that it binds it is using the first parameter is always self. If you're not passing a function any values, you always have to have self. Okay, that's the first use of self. The second use of self is this way of putting it dot in front of the name of a variable. So what's going on here? What is really going on with this little use of self? Well, I'll explain it and then I'll draw a diagram. This bit of code here is familiar, right? That's where you created your head from a circle. What this does is it binds the value to the class. I should use yellow, right? This word self binds this piece of information to the whole class. What it means is that head is now available to any of the methods inside the class. because by using the word self, it's bound it at the top level to the class. Let's draw a diagram. So I'm going to open up that bracket thing just to show you. So what we had inside was, well, what we have inside our class, our stick figure class, is a bunch of data. Let's just say it's called self head, self body, self arms, etc. Now, these are what you call member variables. Variables, member variables. Variables that belong to the class. And it's this word self that binds these variables, head, body, and arms, to the class. Now, that might seem a little bit tricky, but if you think back on global variables, it's a little bit like the global variable. It's a way of actually creating a variable and sustaining it and maintaining its value across different calls of methods or functions, right? I'm interchanging them at this stage so you don't get too confused, hopefully. So the idea is that in the constructor, I create them, and in another method, I might draw them. And in order to draw them, I need to have reference to them, and they need to have kept their original values. So let's just talk that example through. I want to create that in the constructor, the head, and then I want to draw it. So we're going to focus only on the head, and let's see what that code would look like. So we are, as we've said before, inside the class of stick figure. Okay, I'm not going to keep on repeating this because I'm going to run out of space on my screen. Right, so we have, I'm going to use different colors if I can, my double underscore init, double underscore, the word self, and comma, x0, y0, colon. And inside here, I'm going to write self dot head equals circle. And inside there, I've got my point, and my point is built from values, and these two are pumped into here, and I've got my radius, etc. So that builds it. Then in my class, I have a draw method. Again, I use the word self because that binds this draw method to the class. And I'm going to pass it a window to draw it on. So let's have a look at how that code would look. So all I do is self.head.draw and pass it the window. So this is my stick figure class. In my constructor, I've given it, passed it values, and I've constructed it so my head is built, given some initial starting point. I don't draw it in here, I just build it. You might ask the question, hang on a second, if this self head is a member variable, don't I have to state it somewhere? Python is peculiar with this, and Java is clearer with this. Java is actually much better. By using the word self dot before a variable, it tells everyone that this variable belongs to the whole class. And that's a little bit of a problem because it's not that obvious. So what it means is that if I create it with a self.head inside here, later in my code, when I want to draw it, pass it the window, I can write self.head and I can get access to it because it's available for every method in the class. And I do .draw on it and draw it. And that is a massively useful way of maintaining information from one function call in our previous issue to another. Let's have a now in the notes I have, I do talk it all the way through. Let's have a look at how you would use this code, right? So if I want to use this code, somewhere over in my client, I import my stick figure import stick. I've kind of got it wrong. Import stick figure, or from stick figure import star. Let's stick to the same notation. Hang on a second, bear with me. There are two different ways of declaring it, depending on which version of Python you have. It's not so important, right? So we got from stick figure, which is my class, and it's a different file, remember. I want you to maintain that. I want to import everything inside that file. So in my client code, what is it actually going to look like? It's going to look like this. I do my window, graph, win stuff, right? All of that as usual, right? Let's just say I've got some way of getting hold of my point I want to draw it at. So we're not going to worry about the details of that for the time being. Then I'm creating myself a stick figure, and I'm calling it SF from the constructor. Now, how does this work? To use the constructor, you simply repeat the name of the class. You don't write double underscore in it. You just repeat the name of the class. Then you pass it the values the constructor is expecting, right? Remember, the word self, which was inside your class, isn't an external. It's a way of binding that to the class. It's an internal thing, right? It's not external. That's all I need to do to create my stick figure. And all I did in my example from the previous slide was concentrate on the head. But I can have the whole body, and if you look at the code, you can do everything. Then, if I want to draw it, I just do SF draw win. In that single line of code, inside that draw, over and inside my stick figure, I have the methods which draw each of the parts, the head, the arms, the body, and everything. And because of the way that classes work, it's very, very simple to do. But look how simple it is to write that. Now, in my notes, I do give you an undraw, and we look at how to color it. And so what I'm going to do is skip a few pages and just go to one very, very simple last concept, and encourage you to go back to the sheets and work through the exercises yourself and attempt to write the code before you try the end of the lecture material. Now, we've essentially covered the whole of the first week, both lectures. The material for it is contained inside these sequence of videos up to this fifth one. So if you've arrived at this point, then you've covered a lot of ground, and it's hopefully you've paused and gone through exercises. But let's just have one last slide. So far you might agree with me, this has been really useful. Like in my client or my testing code, I wrote, stick figure, and I gave it x0 and y0 with all the rest of it, and I then drew it using a window which I'd sort of sorted out, right? But let's say that I want to also be able to move it by just saying move and give it the distance. So I can move, and this is the beginning of our animation and the logic of objects moving around your screen in really simple ways. I can write, I want to simply just write one line, ask the object and say to the object, move. I don't want to say head, move. I don't want to worry about where the head is, where the arms are, where the legs are. All those details are irrelevant. So look at these three lines I have in front of you. These are concepts. Create an object, draw that object, move that object. How they do it is hidden from you. It's a very, very powerful way of coding, and very useful to you to see it purely as a bunch of concepts. Okay, so how do I actually, if I want to use this, I currently don't have any method called move. So let's write one. So we would return now to our class file and stick figure class, right? As we had before, we have our first init. We have the init code. He says just sketching it out, right? We've got also the code for the draw already done. What we do is we simply add in another method. So we go def move. Always use the first is self because it binds it to the class. Then, are we passing this move function anything? Yes, we are. We are passing it a window. No, sorry, not a window. We are passing it the amount we want it to move by. Right, so let's do that in things. So let's call that dx and dy. Okay, let's turn it back to green. So what goes on inside the code? Well, inside the code, you call the head. And remember, the head is just the circle. It already has inside it a current location because that was done in the constructor. And then we simply call on the head because the move function is also on the circle, is move, and we pass it the distances. Do the same thing with the arms, the legs, and the body, and that's it. So internally, it's actually quite easy to write because it takes advantage of the fact that we've got objects inside objects and objects working, all kinds of stuff. The concept of delegation creeps in a lot here. How actually the head is built from a circle class. The circle class has a move method. So we just simply, in our move method, where we simply call the move method from inside there. We don't have to do any extra work. And that's all we need to do to move the stick figure's head. And you just need to have a line for each of them. Have a look at the code, and you will see hopefully how straightforward it is. It's quite repetitive, but very easy to play with. All the notes that accompany these videos have full code and full sample codes attached on the Moodle site. I'm going to now just bring it to an end in a very final video and summarize and conclude.